invitation and I spoke about the. Okay, we spoke about what electromagnets at the end of the session. Okay, telling how the electromagnets can be used for creating for making magnets. Electricity can be used for making magnets. Okay, so I also said that I'll show you like how to build it and also see like how we can change the poles. Okay, by changing the direction of current. Okay, so for that I just have some. I have this magnet. So let us see, like we'll use this magnet and try to see if we can like the magnet which we are going to create, whether it's going to attract this or repel this. We are going to just see all of those. Okay. Okay. Anybody having the material with you? Yes, no. You can just give a quick answer. Mm, 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 mm. Okay. So I have a nail. What are you doing, Siddhant? Like, you're like filtering something, is it? Oh, is it? Okay. Okay. Good. Okay. So I have a small piece of iron. Okay. Very specifically, we are going to take iron. Okay. Okay. That's okay, sure. No problem. So it's a simple activity. Even after the class, you can do it. Okay. Good. Okay. There's a piece. I have a piece of iron and I have some copper wire. Okay, so then I have like A4 size batteries, and I want something for like a sort of what do you call mm, something which I can lift. Okay, I'll see like what I have around me. We'll do something with that. Okay, there's a small screw in front of me. Okay, fine. Yeah, we'll try to lift that. Okay. Okay, so pretty simple thing, but there's a very interesting concept like which people worked upon. Okay, so I'm going to just like keep turning this wire around this wire around this iron piece. Okay, so I'm good. I don't know like how like what would be the length that might go in. So I've just taken some extra wires so that it doesn't fall short of it. Okay, so the number of turns matters a lot, children. I'll tell you why. Okay, so whenever I do this, I would like to tell a story about a scientist called as Michael Faraday. Okay, so at the one point of time, okay, at one point of time, what happened? There was a big thing, the big thing that was that all the scientists were speaking about was that. So there was a wire that was carrying current. Okay, and near that wire, somebody brought a compass, the mariner's compass, and the mariner's compass was getting deflected. People were wondering like what is happening. Okay, so people thought, okay, so the current is flowing through the wire but nothing should happen around it. So but there was a scientist called Michael Faraday who was imagining things like very nicely. He was very good at imagining. Okay, yeah, very good at imagination. Okay, so what he imagined was that he thought that okay, the current is flowing through the wire, but there is something something is happening around the wire because of the flow of current. So somehow he was convinced. So this Michael Faraday, he was working as an assistant to a bigger scientist, like very popular scientist those days. Okay, what he used to do is during the day he used to just follow the instruction of that scientist, and he used to build his experimental setups for those scientists. But during the night, he and his friends secretly they used to do experiments which they want. Okay, so like that, Michael Faraday one day he thought that he will just try doing it. Okay, what he did was that like he again did the same thing. He allowed the current to flow through a wire, and he brought in a magnetic compass, and the compass started deflected. Okay, deflecting. Okay, But that was just a little bit of proof of like what he was thinking, that there is something happening around the wire. That's okay. But what he did, the next thing what he did was the most important thing, and that's what defined the technology, the future of technology for the entire world. What he did was, so now because in the mariner compass, the needle is deflecting. Okay, the needle is nothing but magnet. In the mariner's compass, the needle that is there, there's a magnetic needle. Okay, so he felt if the current is flowing through the wire and I have kept the magnet free to move, and the magnet is moving. So he wanted to see if to, in physics, that's one important thing, children. The opposite should also happen. So he thought he'll fix the magnet and allow the wire to move freely. And for him, if his principle or his imagination was right, then the wire should start moving around the magnet. So that's what his imagination was. Okay, so he did the same thing. He made a wire to suspend from the top. Okay, so then he had a magnet, and he allowed the current to flow through that wire, and he saw that the wire started moving around the magnet. Okay, so that's the very first time that somebody started telling the concept of an electric motor. Electric motor, what it does, the main definition of electric motor is that it takes electrical energy and converts it into mechanical energy. Okay, that was for the first time that somebody actually showed that yes, using electrical energy you can create mechanical motions. Okay, so that is still, you can watch it on, like, you can see on YouTube or like on any websites. You search it calling Faraday's motor. Okay, it is still popularly known as Faraday's motor because that was the first motor which was built to show the principle of electric motor. Okay, so you can just try doing that. You can just go through that. Maybe in one of the experiment classes, like I'll try to show you the Faraday motor. Okay, so today we'll restrict to electromagnets. So what I do is here, the wires which I put is like they're like very close to each other. Okay, they're very, very, very close to each other. There are not many gaps in between, very little gap, but they're like very close to each other. So that's the fine, that fineness is very required for to have a good electromagnetic field. Okay, so I have little wire that is little long. I want to just cut that part. Okay, so okay, but these copper wire, children, so we call them as the enameled copper wires. Okay, so enameled copper wire, what happens is that, so they have a kind of a nail polish on top of them. Okay, on top of this, there would be a kind of a nail polish. If you just scrape it, you'll see that the nail polish goes out and like there would be a shiny surface that comes in. Okay, so I'm just scraping it only the edges because I need to scrape only the edges because I want to connect the battery to this. Okay, because I want to connect the battery to this to make this work, because if I don't scrape it, then the electric current will not pass through the wire. Okay, so are you able to see this little shiny surface that has come up? Okay, I'll show you just one. I'll just scrape it all on all sides, 360 degrees. Okay, you see a difference between this part and this part, children? This part, it is still brownish in color and this has become little bit golden. Okay, what I have here is, in this part I have removed those nail polish kind of stuff that was there on this. Okay, I'm doing the same here on the other side. Okay, I have done it on the other side as well. Okay, you can see that this is still brown in color and this has changed color to golden shiny. Okay, so that means this is the place where we can connect the batteries. Okay. Okay, there's a small screw here. Let me see if I can like lift that screw using this. So, but one thing is when you connect this, there's a lot of heat as well. See here, I could lift the screw. I'll just remove the wire, and you'll see what happens to the screw. Okay, so it stays for some time. See, because there's something called as a residual magnet. Okay, residual magnet is something like if you charge an iron to become magnet, it might hold the magnetism for some more time. So that's the whole reason the screw is still there. Okay, and then it falls off. See, now I'm trying to stick it. Now I'll not be able to lift it. Okay, because it has lost. Okay, oh, there's still some more what residual magnet left in this. Okay, there's little residual magnet. Okay, there's other way how you can sort of magnetize the iron piece. Okay, okay, yeah, there's one screw. I'll take some more screws, right, so that then it becomes easy. You can see that the screws are just falling off. Wait, I'm just trying it with this paper clips. Let us see. Paper clips are little heavy. Okay, see, now I'm able to lift it. So as soon as I open it, it just falls off. Okay, because of the heaviness of the paper clip as well. Okay, so if it is something lighter, then what happens? There is some the residual magnet itself can hold it, but this is heavier, so that's the whole reason the residual magnet itself is not able to hold. Okay, so I'll open it, and there would be little bit of so this residual magnet completely depends upon the kind of material you take. Okay, so it's not that like for all the iron pieces it will be like that. The residual magnet. Okay, now what I'll do is okay, this will still be attracted. Okay, I thought I'll change the face. Okay, wait, I'll try doing it. It will still attract. Okay, so it doesn't make much difference for the screw whether it is this side of north pole or south pole, right? For any iron piece to attract to magnet, it doesn't make much difference whether it is north or south pole. Okay, fine. So now what we'll do is we'll play with this magnet. So I have I have this magnet. Okay, so now it will surely attract just because this is an iron piece. Okay, so now instead of making it an iron piece, I'll change this into a magnet, and let us see what happens. Even I haven't tried this before, but yeah, I would love to see what happens. Oh, okay, it's attracting on this side. Oh, it's attracting on both sides actually. Okay. Okay, it's attracting. The other side actually it should repel. I think it doesn't have like that great magnetic field. Okay. So the other side, one side if it attracts, the other side it should basically repel. But still I can feel that sense that like on one side the attraction is very strong, on the other side it's small. This side it's very strong, but this side it's very light. Okay, because the force is there's an opposite pole here or the same pole. Okay, yeah, good children. So I'll just tell you like how this works. Okay, I'll write it on the paper. I'll show you what exactly happens. Okay. Okay, so what exactly happens is suppose there's a wire. Okay, on this wire, like we allow the current to flow through this wire. So allowing the current to flow through the wire, in the sense, what we do is we connect a battery. We connect a battery to this wire, So what happens is this, as soon as the electric current starts flowing, there's a magnetic field around it. There's a magnetic field around this wire. Okay, but this magnetic field is not very strong. Okay, to strengthen this magnetic field, what we are doing is we are using an iron piece. For example, you take a nail. Okay, on the nail you basically put these wires, so many turns, and then we are connecting it to the cell. Okay, the iron, what it does is, so last class also we basically spoke about this property of iron. Iron, what happens, suppose there is an iron piece, and in iron piece also all these internal particles, they will be looking for on in different directions. Okay, so as soon as, of course, there would be we have wire on top of this. So there's a thumb rule actually for this magnetic field. Suppose the current is flowing in this direction. Children, please listen this carefully. When suppose the current flows in this direction, the magnetic field is in this direction. The four fingers shows the direction of the magnetic field. Okay, so if the current flows in this direction, then the magnetic field is also in the opposite direction. See, they call this as the thumb rule. Okay, if the current is flowing in the direction of the thumb, then the magnetic field is in the direction of these four fingers. Okay, so if we change the direction of the current, what happens? Again, the direction of the magnetic field also changes. Okay, like this. So this the four fingers are indicating the what direction of the magnetic field. Okay, so that itself makes the magnet to become the electromagnet to become north and south. Okay, so when the current flows through this, okay, what happens, all these particles which were actually looking in different directions, so they will start looking in the same direction as the flow of current. Okay, suppose the current is flowing like this, so then the magnetic field is in this direction, so they all will start looking in this direction. Okay, if they're looking in this direction, then what happens? This becomes north and this becomes south, because the magnetic will start going like this from here and like starting from north and going to south. Okay, so when I change it, what happens? When I change the current, which I allow the current to start from here, starting is children like this. Okay, so this is, suppose I just change the cell, what happens? Then the current will start for positive, negative. If I change, the current will start flowing, entering from here. Okay, then what happens? Then the particles in the iron, they all will start looking in this direction. So that means what happens? So this becomes north and this becomes south. So by changing the direction of the current, the direction of the current from where it enters the magnetic field, we can basically define whether it needs to be north pole or south. Okay, in this case, what happens? You have this, but the current is entering here. Sorry. But the current is entering in this place. So that's the reason. Then all these things will start, all the internal particle will start looking in this direction. And you have like north and south forming. It's opposite. Here you see the current was entering from here and all the particles came here. So this became north. Okay, the current is entering from the other side, this becomes north. So in the electromagnet, it's very, very, very easy to change the direction, to change the phase of the magnet. Okay, okay, that's the whole reason this electromagnet is used in magnetic levitation. They need to change the phase of the magnet very soon. Okay, very fast. They want to change it like very quickly. So that's the whole reason they change the phase of the magnet. Suppose a train is coming here, this is north pole, and you need to have a south pole here for attracting the train. As soon as the train comes just above this or very close to this, because of momentum, the train can just go a little bit ahead. By the time it comes on top of it, you just change the pole to north. So then what happens? It just pushes this magnet. First it is attracting, then you change the pole. Changing the pole in the sense we are not going to physically change. As I showed, it would be electromagnet here. You just change the flow of current, the direction of the current, then it will become like south, and it will just push it because it repulses. Okay, so there's so many small like electromagnets and like at very close distances throughout throughout the track. So then that is what makes the magnetic levitation train to just like float on the track. It just floats on the track because the magnet keeps attracting and repelling the magnet on the train. Okay, so you have small electromagnet, and all these electromagnets, they are basically controlled with the help of a computer. The computer, we know that computer is very fast, right? The computer can basically change the flow of the flow, change the direction of current in a fraction of second. Okay, in microseconds, micro and milliseconds level, it can basically change the flow of current, and that's what makes the ride for the magnetic levitation train very smooth. Okay, good. So let me know in case you have any questions. You can ask me questions. So to test it out, children, it's as I said, like it's not very necessary that you need to have a copper wire. You can also have any wire like this. Uh, a normal wire like this will also work. So you need to just put it around the. I can also show that. Just a normal wire like this will also work for us. It's always not necessary that we require a copper wire. It's like any wire that can carry current. Okay. So I'm not sure on which I have to wind this. Okay, I'll just cut a small piece of this cycle spoke and try to wind it around it. So you need not think that you require a copper wire to do that. No. Okay. Even if you have a normal wire like this, you just like wind it around the iron piece. Nail is a very good thing to use. Okay. Okay. So any current carrying conductor, current carrying wire, it can basically be used for making electromagnet. Okay, at home, in case you just have some wire like this, you can still use them. You need not wait for the copper wire. Uh, there was a screw which I was lifting. Where is the screw go? Mm-hmm. Okay, just one minute. Okay, well, now I need to find a new screw. Just a minute, I'll get a screw. Okay, I'm not finding a screw. What I'll do is I'll just cut this cycle spoke itself into a small piece and try to attach it. Okay, good. Okay. Okay, so as I said, you can also just use this any wire that you have. I should basically carry current. That's what is important. And the number of turns is important, children. The magnet becomes stronger as we have like more number of turns. Okay, I think it's not very strong enough because the number of turns is less. Okay, when compared to this, so this has like there's a whole reason like they recommend the copper wire. Okay, because this has like I don't know how many turns, but this hardly has some 15-20 turns. Okay. So that makes a huge difference. But in spite of that, what you can do is you can always increase the capacity by adding more cells to it. Okay. So let us see if we'll add more cells and see if it can attract. If it doesn't happen, then the number of turns is not sufficient. Okay. So that's okay. Just a minute. It's still not attracting, I believe. Oh no, sorry. So the number of turns is like very less. Okay. I have one more setup with me. See, basically this is an old one which I had done long time back. Okay. You can see this. I have taken a very long nail and put like a lot of turns around it. Okay. We can also see how this works. They are like horribly strong. Okay. So I remove it and it falls off. And you can lift on both sides. It's not necessary because the magnet has north and south. You can also lift it on the other side. So I'll just pull it off one and put it on the other side. Okay, you can lift the metal from both the sides actually. Okay, I release it. You see that like it just falls because when there is no current, there is no magnet. Okay. Fine, children. We just have 2 minutes left. You can ask me questions. Please ask questions. So try this. This is a very simple. This is a very simple thing. And if you ask me like where you will find the copper wire, of course the PrayogPeti box has the copper wire in it. Okay. But like in case you don't have the PrayogPeti box, then you need to like look for it. Okay, and you might get it in the shop where they do this motor repair. You know this mixer repair shops. Mixer repair shop might have this copper wire. You can just buy about 1 meter of it. Okay, so you can buy it from there. What is that? Siddhant, what are you showing? Well, unmute and speak, Siddhant.
So it is a gun that shows the pen. It has the hook like safety pins, and we
Okay.
the refills, and we join the hook and we throw it like in a gun.
Oh, okay. I got it. Yeah, I got it. Okay. Okay. Good. Fine, children. So this is a very simple activity which you can do at home. So actually, as I said, like the PrayogPeti box has all these components, all small things. The best part of using the PrayogPeti box is that you need not search for the material that you require for doing experiments. You'll have like almost everything as part of that. Okay. Good. So in case you don't have PrayogPeti box, then the other option would be that you go to an shop where they do mixie and like motor repair. Like they would surely have this. Okay, you can just take 1 meter of it and like start trying out making your magnet. Okay. So see you then. See you in the next class. The next class I'll do something related to the electricity generation. Okay. I'll do something related to electricity generation to show. Right now we have done from electricity, we have created magnet. So in the next class, I'll show you using the magnet how we can generate electricity. It would be the reverse. In physics, that's the important thing that you can always reverse the scenarios. Okay, from electricity to magnet, we did it in this class, and next class we'll do it from like magnet to electricity. Use a magnet to generate electricity. Okay, we'll do that in the next class. Okay, children, see you all. So bring more of your friends so that like we can form an like online science club. Okay. Fine, children. Ojas. Bye. I did not hear from Ojas today.
Bye, sir.
Yeah. Bye, children. Yeah. See you in the next class. Bye.